The points where a line crosses an axis. I feel like I have some bad grammar here. The points are called intercepts. Bad grammar, sorry. Plural. The point. It would have been better maybe if I just said the point. But there are two. There's an x-intercept and a y-intercept. Almost always, except for vertical or horizontal lines. In any case, the one we mostly concern ourselves with is the y-intercept. The y-coordinate of the y-intercept is the y-coordinate of the point 0y. So it'll always be in this form 0y. Because wherever your line crosses the y-axis, your x-coordinate must be 0. I mean, if it's on the y-axis, we know x is 0 for points on the y-axis. So it will always be in this form, 0, comma, some y value. Sometimes it'll be positive, sometimes it'll be negative. Sometimes it will be 0 if the line crosses at the origin. In this example from the do now, this is the exact equation we did on the do now. So here's a graph of that line. The y-intercept is 4. And the point representing the y-intercept is 0, 4. This point right here where the line crosses the y-axis. Even though this isn't our focus on today's lesson, because it's really important to get a good idea about slope before we try to take in all of this information, I'm giving you like a little bit of preview of what we're doing next week and how we're going to conclude this unit. This is B. B is 4. The y-intercept is B in the mx plus B, and B is 4. The slope, this is what we're focusing on today. The slope of the line is the change in y divided by the change in x. So you see it written here. Slope is change in y over change in x. So now I want to make something clear. Right now, I'm just talking about this little line segment that we have right here. I'm not talking about this other line. We're going to use this other line from the do now as a second example. But just looking at this little piece of a line, this little line segment we have, if I choose 2 points, the change in y, if I'm going from this point to this point, the change in y would be positive 3 because I just moved up 3. So the change in y is positive 3. The change in x, I need to go to the right to get to the other point. 1, 2, 3, 4, 5 to the right. So that's positive 5. I moved to the right, so that's positive 5. So the slope for this line is 3/5 for this line. It's also important to note that while 3/5 can be written many different ways, it's best to write it as a common fraction because slope is expressed as a ratio. It's a 3 to 5. For every 3 you move up, you move 5 to the right. I could go 3 up and 5 to the right and find another point on that line. It's also important to think about the sign of the slope. This line is uphill. And when I say uphill, what I mean is if you were a stick figure walking to the right, always to the right, from left to right, you'd be walking uphill. Uphill is positive. Uphill is positive. Downhill is negative. Let's calculate the slope of this do now, the line from the do now. Let's first talk about that uphill downhill. If you were a stick figure walking on this line, walking from left to right, do you see that you would almost be falling downhill? It's so steep. Do you see what I mean by downhill? If you do, then we expect a negative slope. Negative slope for this one. Positive slope for this other one because we're going uphill on that one. All right. The way you calculate slope, you don't want to have to write change in y over change in x every single time. So there's a symbol for change, delta. Delta means change. So you write delta y over delta x. That means the change in y over the change in x. And let me just Let me label 2 points. We've been looking at that y-intercept a lot, so let's use that as one of the points. I'll label that A. And, well, I've got so many choices, but I don't want you to think they have to be intercepts, but they don't. I could choose this point or I could choose this, but I'm going to choose this point, and I'll label that B. Now I can go from A to B, or I can go from B to A, and I'll get the same result, you'll see. Let's start by going from A to B. I should color code this, I just realized. Let me think ahead a little bit better here. When we're doing A to B, we'll do green, and when we're doing B to A, we'll do purple. Okay, so if I'm starting at A and I'm going to B, I want to consider the change in y over the change in x. If I'm going from A to B, in order to get from point A to point B, my change in y is down. I have to move down 4. So that's a change in y of -4. I went 4 down. And then from there, in order to get to B, I need to move 2 to the right. So +2. So -4 divided by +2, well, 4 divided by 2 is 2, and negative divided by positive is negative. So the slope for this line is -2. Now it could be written as -2/1 if you like to see it as a ratio, but more typically if it can be expressed as an integer, we do express it as an integer. We just never would express it as a mixed number because it's a ratio. Let me get the purple and show you that if I started at B and I went to A, if I go from B to A, now if I'm at B and I'm trying to get to A, my delta y, make sure my y's look like y's, my delta y would be +4 this time because I need to move up 4. Alright, so delta y is +4. But then in order to get to A, I need to move 2 to the left. So that's a change in x of -2. And so if I move from B to A, my change in y over my change in x is 4 divided by -2. Well, 4 divided by 2 is 2, and positive divided by negative is negative. So I get the same slope. I should get the same slope as the same line. It doesn't matter which 2 points you choose on the line, and it doesn't matter which point you start from and which point you move to, as long as you carefully represent your change in y and your change in x with the correct signs, and then you know your integer operations, which I know you know well. Positive divided by negative is negative, negative divided by positive is negative, negative divided by negative is positive, then you'll get the right slope. Now there are 2 examples, the 3/5 and the -2. If you were in the Zoom, we would have also done a couple of the problems on the homework together to get started on the homework, so let's do that.